Hey guys, this is section 3.1. It's about matrices, and there's a fair bit of language that goes with matrices, so I'll just kind of go through these definitions. First off, a matrix is just a way to organize data in rows and columns. So the systems of linear equations we worked with a couple of chapters ago can also be represented as a matrix, for instance. And also matrices always get capital letters for their names. The size or order of a matrix is given as rows by columns, read m by n. That'll be the first example. I'll show what that means. The numbers in the matrix are called its entries or elements. I'm used to saying elements, so I'll probably say that. The position of an element is given by a lowercase letter and a subscript with two numbers. Again, this first example is going to show that. The numbers represent the row and column of the element. Matrices are the same size if they have the same number of rows and columns, and a square matrix has an equal number of rows and columns. So with those definitions, let me do some examples. I'm just kind of going to flip back and forth between these two sheets. So the first question is asking what is the order of each matrix, and this reminds you the order is given as rows by columns. So we have these matrices up here. And so matrix A is this one, so it is 3 rows by 3 columns. So this would be a 3 by 3. Matrix B is 2 rows by 4 columns, so that would be a 2 by 4. Matrix C is 2 rows by 3 columns, so that'll be a 2 by 3. And then this one again is 2 by 4. So that's the order of the matrix. Which of the matrices is square? And so that would be the 3 by 3 one, so that'd be matrix A. So square just means it has the same number of rows and columns. Find the following elements. So remember, the elements were the individual numbers or whatever, for us to be numbers, that are in the matrix. And so we're looking at matrix B, and since it's we know it's an entry because it's a lowercase instead of an uppercase, but this is saying go to matrix B and then look in. Lowercase subscript represented by rows and columns again, so it's that same as the size. So B, and then we're looking in row 2, column 4. So here's row 2 and column 4, so it'll be that -2 right there. And then this one's referencing matrix A, and it's going to be row 2, column 1. So we go to row 2 and then column 1, that would be that 4. C, and it's row 1, column 3. So row 1, column 3 should be that 9. And then for D, row 2, so we're D, row 2, entry 1. And so that's the 5. And then last question here is, are any of the matrices the same order? So remember, matrices of the same order have the same numbers of rows and columns. So here we would say that B and C are both 2 by 4. So those are the same order. I'm sorry, B and D, apologies. Okay, so the next thing is the transpose of matrix. So the transpose of a matrix is formed by turning all the rows in a given matrix into columns and vice versa. The transpose of the matrix A is written A with a little capital T up in what would seem like an exponent. So basically we just have to make the rows into columns. So if I wanted to do the transpose of A, then this first column would become the first row. I'm sorry, the first row is becoming the first column. I said that backwards. And then the second row is becoming the second column. Okay, so scalar multiplication. So this is where we're just multiplying by some, constant value. So we're finding 4a in this case. And what the 4 does is it just multiplies every single element in the matrix. So if I was going to find 4 times a, that would have 4 times 1. So that first entry would be a 4. 4 times 2 would be 8. 4 times 6 would be 24. 4 times 4 is 16. 4 times 0 is still 0. And 4 times 3 would be 12. So that's scalar multiplication. Addition and subtraction of matrices. So if two matrices have the same number of rows and columns, we can add the matrices by adding their corresponding entries. So for this one, we're going to go A plus B. And so what that would be, if I do A plus B, I'm just adding these corresponding entries. So I'll write it all out for this first one and then maybe write a little less on the next one. We'll see -1 plus 7, and then 0 plus 1, and 5 plus, that's 0, -3 plus -1, 2, and then plus 4, and 3 plus -5. Yeah, I'll try not to write that out every time. I just want to show on one of them, I'm just adding each of these corresponding elements. And then we just total that up, which again, I would just go -1 plus 7 would make 6. 0 and 1 makes 1, 5 and 0 makes 0, -4, 6, and if I could read my writing, that's a 5, so that's a -2. Okay, so if we're a class, this would be the question I would have you guys try, which is just a bunch of the stuff we just looked at. So use the matrix to answer the following, so our matrices, so we're using these three right here. First question is to find the transpose of A. So again, this first row becomes my first column, and the second row becomes my second column, and the third row becomes my third column. Find C minus B. So I'm going to write it out one more time. With subtracting, we do have to be a little bit more careful with our signs. So let me just kind of show it this one more time. So 5 minus -2, and then 1 minus 4, and then 3 minus 5. And then here we're going -2 minus 3. And then -1 minus -1, and 2 minus 2. And so then if I put all that together, let's see if we can squish it over here. This will be, if I can again read my handwriting, that's a 2. So 7, and then -3, -2, and -5, that's 0, and that would be 0. Same matrices, this is just, I just copied them onto this page for convenience, so parts C and D. So for this one, we're supposed to find 2b plus 3c, so we've got scalar multiplication and addition happening. So what I'll do is I'll just, and first off we do need to make sure they're the right size, and they are, they're both the same size, so it is possible. So I'm just going to go 2 times this matrix. So my 2b would be 2 times -2 for -4, 2 times 3 for 6, 2 times 4 for 8, 2 times -1 for -2, 2 times 5 for 10, and 2 times 2 for 4. And then I'm adding to that 3 times c. So 3c right here. So I'm going to go 3 times 5 is 15, 3 times 1 is 3, 3 times 3 is 9, -6, -3, 2 is 6. So that's what we're adding. So now I'll just add the corresponding entries. So -4 plus 15, so that would be 11. 8 plus 3, okay, that's also 11. 10 plus 9, so 19. 6 plus -6, so that's 0. And then -2 plus 3, that is -5. And 4 plus 6 would be 10. And then the last question is A plus C, but A is 3 by 3. This is 2 by 3, so they're not the same size, so we can't add them. So we would enter impossible. Okay, this one looks like it's going to be terrible, but it's actually not that bad. So it's just kind of showing, it's just an exercise to make you consider that if these two matrices are equal, then that means that this has to equal this. So these two entries have to be the same. These two entries have to be the same. kind of all the way down the line. So setting these up, I have x equals the 2x minus 5. And so I can just bring the 2x over and get negative x equals negative 5. So now I know x equals 5. That's cool. For the next one, I have 1 equals z. That's pretty self-explanatory. And then I could solve this again to make sure I didn't do anything dumb over here, but I should just get 5 again. So this is kind of a redundant step. So I'll bring the 1 over and get 2x equals 10, and then once again, x is 5. So then y equals 5. So we got there, and there. And then I don't really care about this one because it's just going to be y again. So then I can do 7 equals w plus 1. And then bringing the 1 over, 6 would equal w. So it looks like it's going to be hard, and then it's actually not that bad. One goes, let matrix A represent the sales in thousands of dollars for a certain company in 2015 in various cities, and then B represent all the same stuff in 2016. So write the matrix that represents the total sales. So again, these are the sales, these are the kind, these are the cities. So write a matrix that represents the total sales by type and city for each year. So city is our across the top, and then type is our this way. So city was Chicago, Atlanta, Memphis, and then type was going that way. And so all they're asking us to do is basically just add these two matrices together. So this would be Chicago wholesale this year, and then Chicago wholesale in the next year. So then this would give us the total sales for Chicago, for instance. And so that's what it means by write the matrix that represents the total sales by type and city for both years. So Chicago, for wholesale, the 450 plus 375, so that's going to be 825. And then Atlanta, and so this is Atlanta, both years wholesale, so that would be 580. And then Memphis, the 850 and the 710, so that'd be 1560. And then same thing, but with the retail. So this one would be 810, 350 and 300, so that'd be 650, and that'd be 350. And same exact prompt, this is just part B, and I just put that there for convenience. So this one's write the matrix that represents the change in sales from 2015 to 2016. So what that means is we want to go 2016 matrix B, and then subtract matrix A, because this is 16, this is 15, so we're going to take the difference, which will represent the change. And so it's just going to set up the exact same way as these are. So this is our type, our type in our city. So if we go 375 minus 450, that will be negative 75. 300 minus 280, so that'd be 20. So this one had a decrease, this one had an increase, is basically what we're seeing. 710 minus 850, so that's negative 140. 410 minus 400, so that's 10. 300 minus 350, negative 50. And 200 minus 150 would be 50.